Hello and welcome to the next lecture. In the last lecture, we focused primarily on how do we know that something is wrong with our code or program, and we looked into few indications of something being wrong with our code. In this lesson, we will discuss a few tools in R programming that will help you to debug your code. So let's get started. So what are the tools that R comes with to help you to debug a program? Right, so there are 5 basic functions and a few associated ones that I want to talk about, but the first most basic one is the traceback function. Okay, now one thing I want to say that you can get pretty far in R without using any of these functions. Actually, I worked with R for like 3 years now and I didn't even know that these functions existed. So I'm not saying that you will always be using these functions, but they are actually quite handy in some cases. So the traceback function, what it does is it prints out what's called the function call stack. So typically when you call a function and that function calls another function, and then that function calls another function, and it's like so on. And then you are 4 functions deep, and then maybe the error happens way down there, right? And so traceback just tells you how many functions calls you are in and where the error occurred, right? And so you can try to identify where in the sequence of function calls the error occurred. Otherwise, all you know is that you called one function and then an error occurred, but you have no idea how many other functions are called underneath. So the traceback function will tell you that, and I will give you an example in a bit. Next, the debug function is probably the handiest function. What it does is as you give it a function as an argument, and it flags that function for debug mode. Okay, what debug means? It means that anytime you execute that function, anytime, anywhere, even if another function calls it, it will halt, it will suspend the execution of the function at the first line, and then you can in what's called a browser, and I'll show you how this works, and then you can step through the function line by line, and then you can see you can execute one line, one expression at a time, I should say, inside the function. So you can try to pinpoint, okay, if there's a special line of code, when the error occurs, you will be able to find out which line that is. Okay. The browser function is relative to debug in the sense that you can stick the browser of call to the browser function anywhere in your code, and then when that line of code gets hit, when that browser call gets hit, the execution of the function will suspend. Okay, and then you can go line by line from there. So for example, the debug function will always start the debugging and will start the browser right at the top of the function, but sometimes you kind of want to run through the beginning and then stop it somewhere in the middle, and so the browser function allows you to stick the browser call anywhere in your code, and then it will run the function up until that point and then it's suspended. So there, those two are obviously related. The trace function allows you to insert debugging code into a function without actually editing the function itself, and this is handy if you are debugging someone else's code, right? So for example, there's code in the package and you can't easily edit the code in that package, or there's code in the base R itself, or there's something like that, and you don't want to go and edit that code because you can't find the file or whatever. So you can use the trace function, just insert a little snippet of code, and using that snippet is just a call to the browser function, and then you can kind of browse through that function, and then you can turn the trace off and the function will be back to normal. And then the recover function is the last function. It's actually, I should put it up here, it's related to the traceback. So normally when you get an error, you usually get a message saying what the error was, and then the console kind of comes back to you, and then you can just enter more commands, you can do whatever you want, but execution of that function stops and you get the console back. Well, that's the default behavior. You can change that default behavior by creating or setting what's called an error handler, and recover is an error handler function, which means that anytime you encounter an error anywhere in a function, rather than getting the console back, the R interpreter will stop the execution of that function right where the error occurred and will kind of freeze it there, and then it will print out the function called stack. So you will see how far deep you are in, and then you can kind of jump around to the different function calls to see and to look around. Now you are in the browser and you can look around in the different function calls to see kind of what happened here, how did data get corrupted here, and things like that. It's a little hard to talk about in the abstract, So I will give you the example. These functions kind of allow you to pick apart the details, the lines of code, and try to figure out, okay, nail down where exactly the bug may be. You can also just put things like print and cat statements in your code to print out things. So if you want to know, well, what's the value of x at line 42, you can just print it out, right? And then see what it is. And you can get a lot of mileage out by just putting in print statements. The only problem with print statements and things like that is that if you will put in a lot of these, it will be a long piece of code. You will put in like 40 print statements, and then you are like, okay, I'm ready to go. And then when I go back through and like delete all the print statements, so that can be a little bit of a pain. But you know, there's nothing terribly wrong with it. Some people that I've worked with are actually against the use of debugging tools. Recently, I have a guy, an engineer, who was so against to any debugging tools. He would never use a debugger. All he did was print and print statements basically. And because he thought that the use of a debugger encouraged bad habits, and it's true, I've seen it happen in other places where you just write some code. I don't care how it's going to work. I'm just going to run it. If there's a problem, I'll just run it through the debugger, right? And I will just step through line by line to find out what the problem was. And it encourages kind of a sloppy code development process, because you know that if there's a problem, you can just step through execution with the debugger. And I have to say that's probably not a good habit to get into. It's probably better to think about your code, write it in a kind of intelligent way, and then if there's a problem, resort to the debugger. But since I get to know about these, I use them all the time. I use the browser function, I use all these functions all the time. So I guess I just have developed bad habits, because my bad memory now is burning my brain. And sometime I think I should visit a neurologist to get electric shocks to my brain to fix my memory issue, because it really irritates me sometimes. Just kidding here, don't you think about doing such. Alright, now I'll just give you a couple of examples just so you can see things, see how this works practically. So here's the mean. I took the mean of x and x doesn't exist. So if you take the mean of something that doesn't exist, you are clearly going to get an error. Here you get the error message. This is produced by the stop function, and I call the traceback. It tells me where the error occurs. Well, the error just occurs like right away at the top of the mean function. So the function mean didn't actually call any other functions, right? Because it couldn't figure out, it couldn't evaluate your argument, and so that's where the error occurs. So you know that may or may not be. Many times that is where the error will occur at the top level function. So that in that case, the traceback is not very handy. One thing that's useful about the traceback is when you are communicating with someone else over email, for example me, and you say I get an error when I call, whatever function. It's very useful if we just say I use the traceback after I get the error. And then I can see, okay, what was the list of function calls? I mean, unless the traceback looks like this, then near Debug. But when you are communicating with someone about an error and a function, it's very handy just to print out the traceback so that they can seek out where the error occurred in the hierarchy of functions. You have to call traceback immediately after the error occurs. If you execute some other code and then call traceback, it's not going to work, right? Because the traceback will only give you the most recent error. If you execute another function and there's an error, well, then there's no traceback to give because there's no error in the next execution. So you have to call it right away. Here's a slightly more interesting traceback. So I call lm, which is the linear modeling function. I said y tilde x. So y tilde x, they don't exist. And so I'm getting an error that says y cannot be found. Where did that error occur? Well, actually it occurred several levels deep actually. So here I called lm, and the lm arrow function is a little funky. So I don't expect you to understand all this, but lm called eval on what's called a monoframe. Then that called eval again, which called the model frame function, which called the model frame default. Model frame is a generic function that called a model frame default function. Then it called the eval function again on this, and then at the 7th level here, that's where the error occurred. Okay, so and it basically occurred because it tried to evaluate my formula here, which is y tilde x. That's what the all eval calls are for. And when it evaluated the formula, it couldn't find the actual value of y and x. So that's where the error occurred. So printing out something like this can be very useful. if you are trying to get help from someone else and you are kind of trying to debug your function together. Okay, so that's the traceback there. The debug function doesn't really work well in the static format like this, but I will just show you that basically I could debug the lm, so you can debug any function, doesn't matter if you wrote it or not. So I can debug the lm function, and now when I call lmy tilde x, you get this debugging in the expression that you called. And first thing it will do is it will print out the entire code of the function. So this is a lot longer than this. I just cut it off in the middle here, but the first thing it does is it prints out the whole function's body code. Okay, and then you get this little prompt at the bottom here, the browse to. So now you are in what's called the browser. Okay, the browser is just like your workspace. Actually, you can think of it like a workspace embedded within a workspace, right? So the environment of that workspace in the browser is your function environment. So the things that are in your function are what are in your environment. So at the very top of this function, actually there's nothing in your environment except for the function arguments, right? So what are the function arguments? Well, the first one is the formula. So I have a formula in my environment, which is this y tilde x, but that's it. So anyway, now I can, well, there are actually, I should say, there are other arguments which have default values, but they are not listed here, but they do. I shouldn't say there is more than just a formula because there are other arguments. So here what I do is I press n for next and it runs the first line. When I hit n and then enter, it runs the first line, and then enter again, runs the second line, and enter again the third. I just keep hitting n, so I run and I just execute each line until I get to the line where the error occurs. So when you get to the line where the error occurs and you execute it, you will get an error just like you did before. It's not going to magically fix the problem by itself, but at least you will know where the error occurred. Okay. Furthermore, suppose you want, you can debug functions within the debugger, right? I can call if I want so. So this match.call function, I just kind of stepped right over it, but I could have gone into this function by calling debug on match.call before executing it. And then when this got executed, I would be in the third level of the browser. So these things can nest, and then as you go, they come like a stack of browser frames, right? So you can call the debug function on functions even while you are in the debugger, and you can step through functions even while you are kind of debugging your top level functions. The recover function, so you can set the recover to be this kind of error handler by using the options function. So you say options error equals recover, and that will set a global option, right? So now this behavior will curve over everything you do as long as your R session is open. As soon as you quit, it will go away, and then if you start up R somewhere else, it's not going to save that option. So now what I'm trying to do is I'm going to read that CSV, some file that doesn't exist. Okay, and then you get an error, and you get the error message, cannot open the connection, and you get some warning also. But instead of getting my console back, I get a little menu here, and this menu is the function called stack. Okay, so it's the same thing that you would get back if you call traceback after the error, right? So remember, read.csv that I called is just an equivalent for read.tables. So read.csv called read.table, and then read.table called the file function because we wanted to create a file connection with my file, no such file, right? And then when it tried to create that file function, obviously you couldn't find the file, and that's where the error occurred. Okay, so the error occurred at the third level in the function called stacks. So what you do is you can press a number 1, 2, 3, and then you can kind of browse the environment of that function. So if I want to see what was going on in read.csv, I can just press 1 here, and then it would show me kind of the environment of the read.csv, and then I can break out of that and look at the environment for read.table and etc. And so you can, if you have a very long function called stack, you can kind of jump back and forth to see what was going on at each function call to try out a pinpoint kind of where the problem occurs. Okay, so just to summarize really quickly, there are basically 3 main indications of some sort of problem or condition. There's the message, warning, error, and of the 3 only the error will stop execution of the function. when you are analyzing a function that you think has a problem, make sure you can reproduce the problem, and then you make sure you can articulate what are your expectations and what the output are and how the output differs from what you were expecting, or I would like to say what you are expecting. And so the interactive tools Traceback, Debug, Browser, Trace and Recover can be used, and the keyword actually here is interactive. The reason these tools are useful is because they are interactive. You can kind of do things on the console, and of course the debugging tools are not a substitute for thinking, and so you should always think about writing your code before just throwing it to the wind and hoping that debugger will catch it. So that's it. I hope that you will find this lecture very useful, and if you do, then don't forget to hit the like button, sharing it with your peers so they could learn about these tools as well. And finally, please subscribe to the channel so you don't miss on latest lectures. So see you in the next lecture. Till then, ciao.